Welcome to the Optimum Design Solution. I'm Pankaj Ratnabarki. Once again, we'll start our free online course that is Plastic Product Design and Advanced CATIA. Today, we are moving ahead for the new tutorial for the plastic part door window glass handle design. So, this door handle is used in the car for manual glass up and down. So, this is our overview of our tutorial. So, first step to create the basic sketches. After then, we'll moving ahead for the combined core to achieve the desired shape of the handle. Once we got all the sketches, after then we'll convert that sketch into the surfaces. We'll perform different operations for achieving the different shape and parts of the handle. Once the basic surface is get completed, we'll convert surface to the solid body. Then snapping feature where the handle is get mounted or a lock. So those are the dimensions which will follow during the video. After then, the snapping feature second, roller guider. This roller guider is used to guide the rotating knob. We will add the rib as a strengthening purpose. We'll do the draft analysis for this part. This is the grab knob which guide or a help to roll out the window glass. This is the final door window handle. So without wasting the time, we'll open the CATIA and we'll start for the modeling. So now we are here in the CATIA. So first of all, we'll take the origin and we'll use the axis system. So this is the axis system. Take the origin point, create the axis system. Now we'll hide all the planes. So we'll start for the creation of the basic sketch. So those are the dimensions. So take the plane. So we'll use the bottom plane. Manage the XY horizontal and vertical lines. Start with the first sketch as a center. This diameter. Radius is a 20 and another one is a 11. So this is the 20 mm. Another one. This is the 11 mm. It means 40 and 22. Center distance between both of them is a 95. So now you can see further dimensions. So we'll use this is the 95. So we'll draw this 3-degree middle lines. So give the dimensions appropriately. This is the 4-degree. It means mirror point. This is the exactly mirror to each other, 8-degree, and this distance is almost 12 mm. So follow the process which we are doing. So we'll apply the radius at an initial level. We'll use the mirror command. We'll make it combine join command. Again, so we have to give the radius at this bottom point also. The radius is 25 mm. So this dimension is given 12 mm. So 12 mm. So at the opposite side also, similar way we have to give the radius 12 mm, and further we'll complete our sketch. You can see our sketch is now completely iso constrained, fully green. So first step, that is creation of a basic sketch, part 1 is get completed. Now further we'll select the next plane, opposite perpendicular plane to our basic sketch, and this shape we have to create. This shape is nothing but the shape of basic shape of our handle. So first plane is our bottom and another one is offset by some 20 mm. Since we have to take the references and the middle axis line or a shape of the that particular handle we have to create. So as per the given dimensions, we'll use this 20 mm offset from basic our plane. So this is 20 mm. Then our the baseline radius of this circle is 20 mm and 15 mm again more, so that's why 20 plus 15 35 mm. Similar way we have to create or give the dimensions from top side also. So 11 plus 20 15 mm. So here you can see 15 mm. So now this is the 20 and 11 mm top surface top circles. So now radius 25 and here also 25. So now you can see the reference or a guider sketches get completed. Now we'll use the for this both of circle sketches. We need a combined sketch. That's why we'll use combined curve, so that we will enter into the geometrical surface design. So in the surfacing, we have to go to the we have to set this combined curve. So it is in the operations. No, it is not in this. It is in wireframe combined curve. So first of all, you have to select 1 second, and we will get the result of a combined curve. So this is the central sketch and bottom sketch. On the basic combination, we will get this desired combined curve. So now we'll convert this into the surfaces. So use the fill command. Where is the fill? Yes, fill is here. Fill command. So this whatever the desired shape of the combined curve is get converted into the surface. Now further we'll do the designing. So by using the draft direction, select the line, edge direction 7 mm. We have to add the draft 5 degree, give the appropriate direction, and here you can see the proper draft as per our requirement is get resulted. So we'll see the draft here. So we'll join both of two. So now this 7 mm. Next one is upper side circle and its the bump or a depression. So this diameter 17.5 into 2. This should be at the middle. Same way we have to extract, but the draft is most important in plastic part. That's why give the appropriate drafts. 4 mm upside draft is 3 degree will give. This is the 4 mm. Opposite side also will keep 1 mm because we have to trim it. Now we can see again top surface we have to fill. So use the fill command, select the topmost circular part, and here you can see we'll use the join. So now 2 joins are with us. Trim command, select the first join, second surface, the unnecessary part is get trimmed. So now this is the combined join part. So here the step 3, that is applying the radiuses to the sharp edges. So first one we have to give a 3 mm at topmost edge. Second one we have to provide 2 mm. So by mistakenly I have selected the throughly surface, so select proper edge only, and then this is the 0.5. Okay, so now you can see the step 3, that is the surface creation, is get completed. Now we have to convert this surface into the solid. So once again we'll enter into the part design, take the body, give whatever appropriate name to you. Like I will provide a basic shape. So thickness we have to apply. So thickness definition 2 mm inside thickness. So now this will hide surface because we got final it means basic shape of the solid body. Now apply this sharp edge. We will convert it to the 0.5 radius. So now this step 4 is completed. Now further snapping feature. So this snapping feature might be different with respect to the different vehicles or a different assembly conditions. So as a reference for practice purpose we'll do this snapping. Follow the dimensions. Might be other dimensions are different as per the different conditions where it get mounted or it gets snapped or locked. So follow the dimensions as a reference. So this is 6.267 something, 267, yes. This is 1.5 mm. After then we'll design this shape, but before that we'll apply this draft or angle for this line. So selection should be a proper, don't do any mistake. This is the 2 degree. Yes, we'll once again confirm, yes, it is a 2 degree. Okay, further we'll design this basic shape. This one is a drafted part, straight line and join at the 1.5 mm end line. I will give the basic dimensions. So constraint, to give the constraint or to apply the constraint is important. So this is 1.5 mm. This is the angle 45 degree. This is the dimensions we have to give, 1.5. So our sketch should be fully constrained, so whatever the missing dimensions we have to apply. Yes, now only this parallelism or a 2 degree parallel we have to give. So this is the parallel. So now you can see our sketch is fully constrained. Now we can move ahead for the solid feature. So this is for your reference. Once again we'll see the proper dimensions. Okay, next we'll use the new body and shaft command. By using the shaft command we'll convert this feature. So this is the snapping feature. Shaft command, select the sketch axis and desired result. Apply the radiuses at the corner edges, and after then we'll do the pocket. So before that we'll apply the radius. .25. Now we'll move it for the pocket. Select the positional sketch. Take the desired references. Start for the sketching. Take the reference circle, whatever it means radius or diameter you required. It should be bigger than the our snapping feature. Now this is 30-degree and mirror at the four sides. So start with the basic line, which is almost 30-degree to each. Mirror this line, join this both had to be joined. This is 30-degree. The dimension is a 2.5. 2. No, I think this is a 2. This is not a 2.5. We have to give 2.5 from center. Okay, delete 2.5 from this center. Yes. Okay, so now we have to mirror this at the four sides. So firstly we'll mirror by 180 axis. Okay, so mirror command from vertical axis. After then we'll use the 45-degree reference which we done. Okay, so this select all the lines, 45-degree axis. Yes, so we'll get at the middle side, and we'll again mirror out this from the horizontal axis. So here we got all the four pockets which we can take as a reference. Okay, next, so we'll pocket out this pocket command. Okay, yes, so here this feature is get completed. Next step, so the next step will add a new body, and this is the upper side roller knob holder feature, that is the snapping feature number 2. So this is completed, so this one is a next feature. So same process we have to follow. Take the reference. This is the 20 mm offset plane, that's why we have to take the reference of our basic sketch. So find out where is our basic previous sketch was there. Either we'll go at the background. Yes, we got that sketch. It is in the geometrical surface geometrical set where we completed our sketching. So we have taken the reference. Yes, so now we'll start for the basic design of upper most part. So as we know that this is 95 mm, I will start for the basic shape. So again this snap is there, so here we'll start with the basic. So this is in the angle 3.3 mm. Here you can see. Now we'll drafted angle here. This angle is 1.5. Height is around 7 mm. So give the proper dimension, refer our this video properly. Okay, we'll close this. Now we'll apply the dimensions. This is 1 mm, this is the 2 mm, 2 mm. Then give the angle 45.7. Then this height, this width is there, so take a horizontal dimensions 1.5, and this is the 1.7. Height is okay. So now you can see our sketch is get completed. It is fully constrained. Now simply take the once again we'll take the shaft command and we'll complete our topmost part. Okay, here the desired results are there. So now we have to combine all the three bodies in the single. So take the new body, give the name whatever you want. So this is the final handle, and we will add all the three bodies. So this is nothing but a boolean operations we performed. Now apply the radius. So first of all, ensure all the bodies are get merged. You can see here this body is not properly merged, so we'll apply some additional thickness at bottom side, although it can be damped into the boolean operation. So now you can see once we apply the radius at this area, it will take a proper edge and it get merged with the bottom here. So now here we have completed the basic body and whatever the features are there. Now next one is applying the ribs. Before designing of the rib, we'll just ensure our part draft analysis. So take a material mode condition on, and now we'll just see the draft analysis. So this is the draft analysis. You can see this part is completely clearing the draft direction, and some sliders and drifters are to be required, but remaining part is clear in the draft direction. So here the draft analysis is completed. Now we will start for the designing of the rib. So simply we'll start with the sketch. Before that we'll take the body, give the name rib. So this positioning sketch, take the references of the base circle. So whatever the ribs or a pattern which we have shown in this video, it is only for the reference. So as per whatever the requirement is there, the application based strengthening is required. So as per that you can just select the pattern of the rib. Only the method should be a constant as we are following in this video. As a baseline, as a practice, you will just consider these dimensions. Otherwise, different type of a pattern you can use, zigzag ribs or a straight ribs, which we are following in this video. Only ensure all the rib, its thickness and draft direction, tooling direction. So till that time we'll use the dimension which we are following here, that is 11 mm distance. So here the 4 number of ribs I have added vertically and 1 horizontal, and this semicircular pattern. So now our sketch is get completed. You can see this sketch. Now we'll make a pad by using the thickness command. We'll apply the thickness for this rib. So here select the sketch, use the thickness 1.5 mm neutral, so it equally distributed. And also uh, we have to do intersect, that's why the rib should be properly intersect to our basic bodies. So you can see the rib is get completed. We'll apply the draft to those ribbing parts. So select all the faces of the rib. So we are selecting all vertical faces as they are into the direction where we are tooling out our part. So here you can see all the faces are get cleared or selected. Now we'll select the surface, base surface, from where we have to apply uniform draft. So first of all this surface we have to select, then draft direction. So 1 degree, just check whether it is as per or inline in a draft or a not, draft direction, tooling direction or not. Yes, we have to make a reverse, so minus 1 degree. So you can see this, all the ribs are clearing the draft direction. So now further we'll moving ahead for the intersect command in the boolean operation. So now we'll for intersect just copy our base body, paste directly, we are pasting it. We'll delete this radius because we have to apply inner side thickness. So first of all we'll define the body, we'll select the face, and we'll apply the inner thickness as a 4 mm. So it made 4 mm is too much large, 3 mm. Okay. So here our body is get completed, which we are taking the reference for intersect. Now final ribbing, intersect. Okay, so you can see this internal ribbing is get completed. Now we have to add this rib into the body, main body. So here the rib pattern is completed. So further you will add whatever the radius is, which are it means the sharp edges should not be there, that's why apply the radius. It will take more time, that's why we'll skip the operation. We'll directly move ahead for the next, that is the grab knob design. So this is the grabbing knob which is get locked into the snap which we have designed at the top part. So it is a rotating roller type of an grabbing knob you had seen into the old manual handle where for the window glass up and down in the cars. So take the references which are necessary for the design. And same the dimensions which we have taken for the snap, with the reference of that snap also we have to design our uppermost grabbing knob. So those are the dimensions, just follow. So these dimensions, first of all we'll apply the thickness 1.5, After then give the topmost 7 mm radius, distance 7 mm. Then we'll try to complete the basic shape of the sketch. So this is not required. Firstly we'll complete the basic sketch. So follow the dimensioning which we are adding in this video. So almost all dimensions we have given. Our sketch is now becoming the fully constrained. So here we got a full constrained sketch. Only the this chamfer is required, because this chamfer is allowing to enter that knob and fixing by press fit at an entry level. That snap is required. This radius is we have to give. So here almost dimensions are get completed. Sketch is completed, fully constrained. Now we'll moving ahead for the shaft command. So the shaft is get completed. Now we'll add the serrations, crabbing serrations. That for that we'll use the pattern command. So take the references. First of all we'll draw the rough sketch. Take the reference of the existing sketch. Parallelism. Okay. So here again we'll do the shaft command, and we will use the pattern. Before that we'll apply the radius at the sharp edge. So now pattern, complete cone against the 360 degree. Okay, so here you can see the grab handle and its rotating or a roller type of a knob is almost get completed. So this video is now get completed. We have converted whatever our today's task, plastic design. So request you please follow our YouTube channel, subscribe our